Hi, I'm Alistair, I'm a games designer, and in this video I'd like to teach you how you can use a thermal printer such as this one as part of an escape room prop. Now these printers are very inexpensive. This one cost about £16. It runs off a 5-volt DC power supply and it has a serial interface, which means it's very easy to connect to a Raspberry Pi or an Arduino. This one here I've actually got connected to an ESP32, and this could be running some other electronic puzzle in the escape room somewhere, which when players solve causes the printer to print out a message or code that they then use in another part of the room. Or perhaps you'd like to use this as a hint delivery mechanism. So let's say you've got a games master that's observing the players somewhere and they need a bit of a hint to get past a puzzle that they're stuck on. The games master could remotely send a message to the device here and print that hint out to the players in the room. So to demonstrate that, I've actually created a little Node-RED dashboard here. So this is running on my Node-RED server locally, which is connected to the ESP32. And I've kind of set up some common tasks there which the games master might want to send to the players. So first of all, just to demonstrate that's actually connected, I've just put an LED toggle at the top here. So when I click this toggle on and off, you'll see it toggles the built-in LED light on the device there. That's just to show they're connected. And then I've got some predefined hints. So let's say that we commonly observe that players get stuck in these places, so we'll actually create some hints for them. So let's say, did you hear a noise, for example? When the games master sends that hint, you'll see it prints out on the printer there. Oh, if I can hopefully show that. Do you hear a noise? There we go. Check your coat pockets. We might send that as the next hint. Look under the table, whatever. Or maybe we want to send a custom message. So if I click in the box here, I can type, you need the code 1234, for example. And when I send that, you'll see that hopefully gets printed out the bottom there. There we go. You can actually send more complex messages as well. So here I've got an image, which is a sort of a kind of like a pigpen code. And if I click that, and so it takes a little bit longer to print out, but hopefully if I hold that up to the screen there, you'll be able to see and hear that message being sent to the players. So you can define really as many different ways of using this as you want. These could be triggered automatically by other props in the room, or they could be manually triggered via the intervention of a games master. So the reason why I like the idea of using printers in an escape room is that they're a way of delivering dynamic, custom information to players, but in a format that is physical and tangible. So as a player, the thing I like about escape rooms is that everything's so hands-on. You know, with a puzzle, I expect to get levers and dials and buttons and knobs to turn. But if they just lead to an LED lighting up or a monitor display or something like that, it's kind of taken away from that physicality. Whereas with a printer, if I solve the puzzle, I can physically see the paper getting fed through with my message on it, and then I can sort of rip off the code I've received and carry it around the room, and that really heightens the experience for me. From a technical point of view, they're actually really simple to use as well. If I just open it up to show you what's inside, so you'll see that compared to an inkjet or a laser printer, they are incredibly simple mechanically. There's barely anything in there. So there's no need for ink cartridges, you don't need toner, anything like that. All you do is get some thermal receipt paper, so exactly the same thing that you get in a receipt printer in a shop. And this comes in a standard width, so this is 58mm receipt paper. And you kind of drop that into the box, just make sure there's a little bit popped through, and you close the lid, and that is literally ready to go. In terms of the wiring, I mentioned, so this is a 5-volt DC power supply. Now I've got a separate power supply here. It draws about an amp of current, maybe an amp and a half when it's printing. So you want to have a separate power supply. Don't run it from the 5-volt supply of your Arduino. And then the serial interface, like I said, there's actually several wires come off there, but a lot of these aren't used. The main one is simply a transmit and a receive line, and also a ground, which you get going to whichever processor you want to choose. Now, even if you're not interested in using a thermal printer in your escape room, the other thing I'd like to try to demonstrate in this project as I go through is a way to design code that can run on multiple devices. So I'm using an ESP32. This is using a Wi-Fi interface that's built in to connect to my MQTT server. That's how I'm sending the data to the processor to print onto the printer. But I could be using an Uno, which has got a wired Ethernet connection. Or I could be using an ESP8266. Or maybe I've got an Arduino Nano. Well, that doesn't have built-in network connectivity, but I could send data via the USB serial connection instead. So as part of the code, when I get on to show you that in a moment, I want to kind of highlight all those different hardware choices you can make and how you can design code that is able to adapt to whatever functionality of the board that you're choosing to run it on. So here in Fritzing, I've got 5 different microprocessors, and I'm just showing how you would wire each one up to the thermal printer. I've got an Arduino Nano, an Uno that's got an Ethernet shield on top of it, a Wemos D1 Mini, which is based on an ESP8266 chip, and then I've got an Arduino Mega and an ESP32. Now, the wiring is actually very similar in all these cases. There's a serial interface that connects them to the printer itself, but there are a few subtle differences between them, so I just wanted to kind of illustrate every example I've got here. Let's start off by actually taking a look at the printer itself in more detail. So on the underside of the printer there are 5 wires coming out, and there's actually a little legend on the bottom of mine that does have labels for each of these. So I've got NC, TX, RX, DTR and GND. And with the cable harness that came with my printer, they were coloured black, blue, green, yellow, red. So the first thing I just really want to draw attention to is that the ground connection goes to the red wire on the cable. That is, I've never seen that before, it's very unusual. Red almost always is positive voltage that I've seen, and black is normally ground. So do not connect that to +5 volts or anything like that. The red lead, certainly on mine, is the ground connection. And then you need simply 2 other connections. You need the transmit from the printer, and obviously that goes to the receive pin on whichever processor you're using, and then the receive pin on the printer goes to the transmit pin of the controller you're using. So that's a very simple serial interface. You don't need to connect the NC wire, and you also don't need to connect the DTR wire. That's for more advanced printing functionality, and there are some examples you can find on the internet about how you can use that to kind of avoid the buffer that's on the printer and print a bit faster, but I wouldn't personally worry about it. Just connecting these 3, the TX, RX and ground, is perfectly good enough. So ground on the printer always goes to ground on your processor. In terms of the transmit and the receive lines though, well, the pins you want to use for those differs slightly from processor to processor. So let me give you a few examples in detail. If you're using an Arduino Nano, that only has a single, what we call hardware serial interface. And that's what's used, it's shared with the USB connector here, and that's how you upload sketches to the Arduino in the first place. If you use the Arduino serial monitor, so you use commands like serial.print to output information back to your PC, that is using that hardware serial interface already. So to create a serial interface for the printer, we're going to have to create what's called an emulated software interface. And you can do that using the software serial library that comes with the Arduino IDE. And you can create a transmit and receive interface on any spare GPIO pin. So here I'm using pins 2 and 3, but you can basically use any pins at all you want on the Arduino, so long as they match the constructor that you create in code, which I'll show you a bit later. So that's nice and straightforward, and I've got the ground going to ground. We then also have a separate 5-volt power supply coming in here. The printer draws a little bit over an amp of current when it's running, I find. So this really wants to be on the safe side. I would use a 5-volt 2-amp power supply here, just to create enough power. So we're not powering it from the Arduino, but we are just sharing a common ground connection here, and we'll power the Arduino separately, either through the V-in, the 5-volt socket, or the USB socket. Now, if you're using an Uno, and here I've put an Ethernet shield stacked on the top of the Uno. The reason for that is because then I can send commands to the Arduino to print over a network. On the Nano, which is obviously not network connected, I could use the USB serial link here and send a serial command from my PC. But on the Uno here, I've got an Ethernet network connection. And the implications of that is that actually uses some of the pins up on the Arduino. So particularly it uses all the SPI pins, so 10, 11, 12 and 13 along the bottom here are used for the interface to the Ethernet shield itself. If you're using the style of Ethernet shield that comes with an SD card like this one does, it also uses pin 4 as the SD card select pin. So similar to the Nano, you can use any spare pins, but note that these ones I've mentioned here are already used. So use some other ones basically. Again, 2 and 3 is actually fine. The Ethernet shield is not using those. And you can use the analog pins that are on this side of the board as well if you're not using those for anything else. Okay. Then we get onto the Wemos D1 Mini. Now, you haven't got so many pins to choose from on this one. This board is a nice compact board, but it actually only gives you 8 GPIO pins to choose from. But so long as you're using some that you're not using for any other function, you can pick what you want to. The advantage of the D1 Mini is that it has Wi-Fi built into it. So whereas we had to stack an additional shield on top of the Uno to get network connectivity, here we can just create a Wi-Fi interface. It doesn't need any additional pins, so we can just use all of the available ones here. Now note that when you address pins in your code, if you're using one of these boards, it's a little bit complicated. The pin numbering system has to be prefixed with a D. So on the board here you can see I'm using D3 and D2. And you do actually need to call those D3 and D2 rather than just 2 and 3, which is what you'd normally use on an Arduino board where they're just labelled with numbers. So just be a little bit careful of that gotcha with that board. Then we go on to the Arduino Mega. Now, the Mega does not have Ethernet or Wi-Fi built into it. However, it does have several hardware serial connections. It's got 4, in fact. So it's got the hardware serial interface that's used by the USB connector here that we spoke about earlier, but it's also got all these additional serial interfaces that are on this side of the board here. So if you're using a Mega board, you don't need to use the software serial emulation on one of the pins up here. You can actually use an inbuilt hardware interface. That is going to be faster, it's going to be more reliable, it's used less memory on your code because you're not having to try to kind of emulate this stuff in your code. It's actually built into the hardware chips on the board. So what you need to use is you can use the TX3 and RX3, TX2 and RX2 here, or this one here. So I'm using the serial 2 interface here, which transmits on pin 16 and receives on pin 17. And what that means is in the code we can actually specify to use the serial 2 interface, which I'll show you there. So that's a more reliable way of connecting, but notice it still doesn't have a network interface here, so you'd still have to add that. If you wanted to communicate over a network, you could either add a shield or you could add an additional bit of hardware like an ESP1 or something like that. Which brings me on to the ESP32. Now this is my current favourite processor of choice, it has to be said, because this basically combines all of the benefits of the previous boards. So we've got our USB adapter on this side. The ESP32, like the ESP8266 up here has built-in Wi-Fi, so we don't need to add any additional hardware to create network connectivity. We can create a Wi-Fi interface straight to it, and it also has multiple serial hardware interfaces like the Mega did. So you can see on the board here I've got pins labelled RX2 and TX2, and I'm using those to connect to the TX and RX lines of the printer. I've also got ground going to ground. So again, in the code we don't have to use a software serial interface. We can actually use a built-in additional hardware interface. So that's going to make our code a little bit smaller, a little bit faster, and more robust. And also we don't have to add any additional hardware to add the network connection. So this is my current board of choice. It's also got loads of extra features that we're not using in this particular project, like Bluetooth and touch enabled pins and all these things as well. But whichever board you choose to use, those are your different options available. Like I say, the wiring is actually pretty straightforward, and you're not actually going to do any hardware damage by plugging your transmit and receive lines the wrong way round. It simply won't work. So should you end up actually connecting them backwards, don't stress about it too much. You can always just try plugging them the other way. So that's your kind of wiring options. Okay, so here's the code. Now it does look like there's quite a lot here, but the reason for that is because I wanted to allow for all those possible combinations of hardware. So it might be that you have a device that only has one hardware serial port, or you might have several, and maybe you've got a Ethernet interface, or maybe you've got a Wi-Fi interface, or maybe you're using the serial interface. And I wanted to sort of demonstrate how you could write code that would actually run across multiple devices depending on the hardware capabilities it had. So within the code here you'll find lots of sections that actually only get executed on particular devices, but the code base itself contains all of them, and then when you actually come to compile it and upload it to the board, depending on which platform you chose up here, it will only include those sections of code that are actually relevant to that piece of hardware. So I'll step through each line of the code, but if anything's not clear, you can always ask a question in the comments below anyway. I pretty much always lay out my projects with the same basic format, so always begin with a section of definitions at the top. Now I commonly have a definition that says define debug at the top, and this is to kind of enable a debugging mode so that there'll be additional information sent to the Arduino serial monitor later on in the code. Here, however, I've got a slightly more kind of fundamental change to the way the code operates. So depending on the value that's defined up the top here, there will actually be whole sections of code get executed differently depending on how you're going to send the information to the printer that's going to be printed. So you've got three choices, whether you'll send that over an Ethernet connection, over a Wi-Fi connection, or over a serial connection. And that relates to the different types of hardware board which I showed you earlier. Here I've got use Ethernet defined, but I'll show you the different sections of code that differ depending on which one you've got anyway. Then we go on to the includes. So includes are the extra libraries which we're going to include in this code sketch. And there's a couple of them I'm making use of. But again, they depend on the particular hardware you're using. So this first one here, I've got it wrapped in a conditional code block here. So there's a flag here that says have hardware serial to. That is defined if you're using an Arduino style board that has at least 2 additional hardware serial ports. So that basically means the Arduino Mega. This flag here is defined if you're compiling for an ESP32 board, which, as I mentioned earlier, also has 2 additional serial ports. So if neither of them are defined, that's what the exclamation marks are there, then I'm assuming we're running on a board that only has 1 serial port, and we're using that already in the USB connection. So what we're going to do is we need to emulate another serial port using a pair of GPIO pins, and that's what this does here. So we'll include the software serial library, and then we will use that software serial library to create a new interface called serial2, and we'll use the receive pin 2 and the transmit pin 3. Like I say, if you're creating this on one of those WeMOS boards, you would have to put a D in front, and if you wanted to use a different pair of pins here, you could just put them in the constructor here. So you could say 9 and 10, for example, or A1 and A2. Okay, but this whole section here only gets included if we need to. If you've actually got hardware serial 2, we're going to use that instead. Then we go to include a library here called thermalprinter.h. So this is actually a library which is on my GitHub page here, and that just includes some functions that send commands to the printer. So not just printing text, but if you want to put in a line break, or if you want to change the size of the font, or whether it's bold print and things like that, that includes library functions for the thermal printer library there. This next section here, so this only gets included if we've chosen to use the serial interface to send commands to the printer. So not to get confused here, this serial interface, this is about the serial interface from the Arduino to the printer. But this serial interface here, this is about from your PC or from whatever device it is that's sending the data to the Arduino or to the ESP thing. So we've got two different serial interfaces going on here. And I'm including a library here called CMD buffer. This is a library that's going to help us extract and pass commands that are sent over the serial interface. So for example, if we send a command, I've got some examples up at the top of the code here. So let's say we send the command feed3. Well, that's going to say, okay, what we want to do is to send a line feed command, and we want to line feed 3 blank lines. Or if we want to print something, we say print, and then we put the text that we want to print in quotation marks. What this CMD buffer library is going to do is it will receive this whole byte string here, and it will allow us to extract this part, which is the action to do, and this part, which is the parameter to apply to that. That's what this this library does here, and it just comes with 3 parts here, so you have to include all 3 of them. But we only need to include that if we're using the serial connection. If we're not including the serial connection, okay, well, what are we doing instead? If we're using an Ethernet connection, then we need to include the Ethernet library. Or if we're using the Wi-Fi connection, then we need to include the appropriate Wi-Fi library. And confusingly, there's actually 2 different ones to include here as well. If you're on an ESP8266, the library is called ESP8266 Wi-Fi. If you're on an ESP32 or on any Arduino board, so that's what this line here means, it's just called Wi-Fi.h. And then this last section at the bottom here, whether you are using the Ethernet or Wi-Fi, we're going to send messages via MQTT. So this is one more library that I include here. You can get it from this GitHub link here. I've used this in lots of projects before. It's how I connect pretty much everything to Node-RED, and you can use it to connect Raspberry Pis and ESP32s and Android and PC devices, lots of things. It's a really good lightweight messaging system. And that one I'm including whether you're using Ethernet or Wi-Fi. So hopefully you followed that. This kind of if, end if defined, else, things like that. It's just a series of logical statements to decide which bits of extra libraries we want to include depending on what was chosen at the top here, and also the capabilities of the board we're using. But it means that for any particular time you compile this code, it actually only includes what you need. So it's quite efficient when it actually runs on the board. Okay, then we look at some constants. So these are values that are not going to change over the lifetime of the code. And again, we've got some slightly different things depending on what combination of hardware we're using. If we're using a Wi-Fi connection, then we need to define the name of the network we want to join and the password we want to join. I mean, this is my network, but there's no particular value in those numbers there because I've actually changed my router since I've recorded this video anyway. But you'd obviously supply the name of your Wi-Fi here and the WPA password used to connect here. If we are using either the Wi-Fi or the Ethernet, we're going to need to know the server to connect to. So this is the IP address of the server that's going to be running the MQTT broker service, and that's the port on which the server is running. So you change this to the IP address of whatever your local instance is that's running Node-RED. And we also need to provide a name or an ID that's going to uniquely associate this device on the MQTT network. I always use 3-digit numbers to refer to the device on my network. So kind of the first digit will let me know the type of device it is, and then the following two actually give it a unique ID. So if you have, for example, a multiple room setup, the first number might represent the room in which this device is located, or it could be the type of device, so whether it's an input or an output, or whether it is a whether it's a Raspberry Pi or an Arduino or something like that. You can use whatever system you want, but it just needs to be unique on your MQTT network, that's all. If we're using the serial interface, we don't actually have to define any constants at all, so there's nothing for the serial interface to decide there. And then we go on to globals, so these are shared values between all the functions in the rest of the code. So we need to actually create an instance of our printer object. So this is from the thermal printer library we included earlier, and we're going to tell it which serial connection we're going to use to interface with the printer. So I've called that serial 2 here. Now, remember, if you had a device that had 2 hardware serial interfaces, so either a Mega or an ESP32, that serial 2 already exists. You don't need to do anything about it, you could just refer to that in your code anyway. If you didn't already have 2 serial interfaces, that's when this line here came into play, and we actually defined an interface called serial 2, which was a software serial interface on these 2 pins. So one way or on another, this serial 2 should definitely exist at this point, and it might be a hardware interface, it might be a software interface, but the printer doesn't actually care. All it needs to know is what is the serial interface you want to use. So that's what that line does there. If we're using an Ethernet connection, okay, great. What we need to do is create an Ethernet client, and we also need to create an instance of the pub subclient. So this is the MQTT library. So we'll create an MQTT client that uses the server that we defined up here on the port, and it uses the Ethernet client. If we're using Wi-Fi instead, okay, well that's almost exactly the same, except we create a Wi-Fi client this time, and then we create a pub sub client that uses that Wi-Fi client instead. Okay, fine. If we're using a serial interface, however, to send commands to our processor, then we need to create this CMD parser. So remember, this is the library I said that's going to help pull out the sections, so the instructions and the parameters of a serial message that we send to the device up here. And there's kind of 3 components to it. So the first one is how big a buffer we want to create. So the buffer is going to hold the entire message that's sent over the serial connection. So it's got to be as least as long as the longest text message you're going to send to the players. You can obviously send multiple messages one after another that are shorter than that though. So I've said 200 bytes for the length of my command buffer here. And that sort of works. That's enough to write, you know, a pretty decently long sentence like "Have you remembered to look under the bookcase?" or, you know, "Check whether the key fits in the blue lock," or something like that. It needs to have a little bit extra on the end as well, because in addition to the message itself, it's actually going to have the action at the front. It will have to have a trailing character at the end, and these speech marks here. So just make sure that that is long enough to contain the entire length of the message you want to send. We're going to define a number of what's called callbacks. So a callback is a function that is executed in response to some kind of trigger received. And in this case, we're going to define 3 callbacks. So they can either be to print a message, they can be to feed some amount of paper through the printer, and I've also just included one which turns the onboard LED on and off as well. Particularly when you're testing something like this, you don't want to kind of get through consumables. So I don't want to get through reams and reams of receipt paper when I'm testing this. So what I'm going to do instead is just light the LED on and off. That will let me check that the board has received the incoming message okay, and it's passed it and processed it without actually having to print a load of unnecessary paper through each time. So I've got 3 different commands. If you wanted to have more commands here, you could add them, but 3 is enough for me to the way I want to use this device. And lastly, we actually need to create an instance of the parser object itself. So this has no parameters, but this is what's going to take the contents of the buffer that we define up here, and it's going to extract the commands which call back these functions that we use here. So these kind of 3 all work together when you're sending instructions over the serial connection. Okay, then we get to the setup function. So this executes when the code first starts running. We initialize the serial connection to the PC. This is going to allow us to monitor any code if we use a serial.print output here. It's also actually how we're going to send data to it if we're using the use serial option. We'll also begin the secondary serial connection. So this might be that hardware connection, it might be a software connection. It's going to be running at 9600 baud, which is the speed at which my printer expects to be communicated. If you have a different printer, it's possible that this connects at, say, 57,000 baud or different baud rates. You can just adjust that there. We call the printer init function. This just initializes some default values on the printer, like I say, things like the font size and the line spacing and things like that. And it gets it set up ready to use this serial connection here that's connected to. And because I mentioned I'm using that LED on board as kind of a test output, we'll initialize the built-in LED on the board as well, just so we can see where that's running. And then what we need to define is, okay, well, we've set up these interfaces, the Ethernet or the Wi-Fi or the serial interfaces. We need to tell more about the different commands and how to respond to them now. So again, we've got some conditional code sections here depending on which interface we're using. If you're using the serial interface, what we'll do is we'll register those 3 commands that we want to respond to. So an incoming serial message might begin with the command print, or it might begin with feed, or it might begin with LED. And there are 3 corresponding functions that we want to call when those commands are received. And they're called printout, paperfeed, and LED. And those are actually defined at the end of the code. So I will just quickly skip there just to show you them. So here we've got the printout, paperfeed, and LED. So printout calls the printer.println function, and it sends it the first parameter that the serial command parser was able to extract. So this function got called because the first line of the serial input was the word print, and then it sends to the printer whatever the parameter to that function was, the thing that comes after the word print, basically. This function gets called if the first piece of data in the incoming serial message was the word feed, and then it sends to the printer.feed command whatever the first parameter after that feed command was, and it calls the a to I function. So this is converts an alpha to an integer. So basically, rather than it being the word 10, it converts it to the number 10, and it will feed that many lines through the printer. And then the LED function, well, this gets called if the first command in the incoming serial data, if that is the word LED, And then we've got two possibilities here. It could be that the next parameter after the word LED is the word on. And if it is, what we'll do is we'll write a high value to the built-in LED. If anything comes after the word LED other than the word on, though, we'll turn the LED off. So if you write, LED 0, LED kill, LED or whatever, dim or something like that, it will turn the LED off. I could have actually made it so you have to specify the word off there by just writing a single line there. But I thought, okay, well, if you write on, I'll turn it on. Anything else, it turns it off. So those are kind of helper functions for the serial command callbacks that we've got up here. Alternatively, perhaps we're using the Wi-Fi interface. Well, if we're using the Wi-Fi interface, we actually need to start that up when we're in the setup function. So if we're on an ESP3266, the first of all thing we'll do is make sure that the Wi-Fi is in station mode. So rather than acting as an access point or a Wi-Fi hotspot, we want to ensure that the ESP is actually acting as a client that it's connecting to another network, because it will act in both modes. And depending on your board, I found that sometimes you need to specify that explicitly. I kind of think it's meant to be a default mode, but sometimes I found boards don't correctly do that. So just to specify that we want to act as a Wi-Fi client and join an existing Wi-Fi network, not act as a Wi-Fi device that other devices connect to. That's what that line means. We'll begin our Wi-Fi connection using the SSID and the password we supplied in the constant section at the top of the code, and we'll then just wait until we get the status message that we've been connected to the Wi-Fi network. When we've done that, we'll just print some output that says done, and we'll print the IP address that we've been assigned by the router. Alternatively, if we're using the Ethernet connection, so similar, we also need to initialize our network interface, but the way to do that is slightly different. So we'll specify the MAC address of our hardware. If you've got a new style Ethernet shield, you might find that the MAC address has been printed on the board itself. If you haven't got one, you can just make it up. A little bit like with the MQTT ID at the top of the code, it just needs to be unique for the network that you're on. I mean, technically it's meant to be really unique, like anywhere on the internet unique, but assuming that you're not going to be joining a public internet with this device, it doesn't really matter. You can just make something up here. You then have the IP address that we want to be assigned to this device. Now, if you just want to have an IP address assigned via the DHCP of your router, that's fine. You can leave that blank and you can just call Ethernet.begin like that. However, if you do that, you'll find that your code actually is a bit more bloated, it's a bit bigger, because it has to include extra functions to handle the DHCP allocation of the IP. So if you are able to specify a static IP address here, I would always recommend you do so. And in fact, it's generally kind of good practice anyway, I think, rather than rely on your some part of your network configuration to arbitrarily give you an IP address. If you know the IP address of every device on your network, you'll find it much easier to debug any issues later on. And Lord knows there can be a lot of issues when you're trying to debug network devices that aren't working. And then again, once we've begun our network connection, we'll print out the IP address. So that, in most cases, that will match whatever you actually asked for here. But if you chose to leave that blank and be assigned a different address, that will get whatever address was assigned. Okay, so we've created our network interface. Or if we're using a serial connection, we've specified the commands we're going to respond to. What we now want to do is to specify how we're going to respond to MQTT messages. So this is another kind of callback. So we had the callbacks up here that related to the serial interface. This is the callback that's going to happen for messages that are received over MQTT. So it takes a function signature like this. Now, I've spoken about MQTT in previous projects, and there's lots of other resources you can read up about in various places on the internet as well. Anyway, but the idea of MQTT is that you have a message that's been published to a particular topic, and any number of devices can listen to topics, and when a message gets published there, they can receive them and act upon them accordingly. So the first thing we're going to do is we're going to you'll notice that the message itself is referred to as a payload here, and it's a byte array. Well, let's convert that to a character array first of all, so we can do something useful with it. Again, I'm assuming a maximum length of 200 bytes here for the maximum size of the message that's going to be received, just as I was with the serial interface up there. We'll copy whatever this payload was into our new message thing, and we'll put a trailing terminator on the end, so it makes it a valid character string. We'll just print out a bit of information here just to say we successfully received a message over MQTT, and we'll print out what that is. And then just as we had our helper functions before that behaved differently depending on the serial command received, we've got functions here that act differently depending on the message or the topic that was received. So you'll see I'm mirroring the functionality based on the different hardware that you might be using here. It's exactly the same functionality, but just implemented in a different way. So we'll use the str function that compares whether a particular character string appears in another character string. So if the topic contained the string print, that's what this line here means, then we know what we're doing is we've received a command to print a particular message, so we will print the message. We'll send printer.println message, and we'll also just debug some output there. Alternatively, if a message was received in the feed topic that we were subscribed to, well, again, we'll call a to I to convert an alpha character string into an integer, and we'll call that number of line feeds. And assuming that we were able to convert that successfully, so if number of line feeds is greater than 0, we will feed that many number of lines to the printer. Alternatively, if the value after feed was not a number, we'll just feed a single line through. So that's what that line does there. A little bit more debugging information. If the topic published had the string LED in it, however, then we've got two possible options of what to do, depending on whether the message was on or the message was off. So if the message was on, we'll turn the LED on, and if the message was off, we'll turn the LED off. So actually, I've kind of didn't notice at the time, I've written slightly different behavior there than I did with the serial interface. With the serial interface, you actually had to write on to turn it on, and anything else would turn it off. Here I've said that we've actually had to explicitly enter the command off to turn it off, so that's bad of me to not quite implement the same functionality there, but you can compare how the example. So all of this section here is executed for the Wi-Fi and the Ethernet examples, and it mirrors exactly the functionality that we had here for the serial examples. So we're still in the setup function. The last thing we do, well, I've just put a little bit to configure the printer, so I'm setting the size of the printer to S. Again, I was mainly doing this so that when I'm using it, I use the least amount of paper possible. If you were using this to actually deliver clues to players in the room, you might want to make that a little bit larger. Although, to be fair, S is still perfectly readable. And it does mean that you can get more characters on a single line of that 58mm receipt paper. And phew, we got to the end of the setup function. Thank goodness for that. Now, finally, we get to the loop function. So this is actually the final section of the code. We've looked at everything else. This is the main program loop. Unfortunately, it's not actually very long. If we are using the serial interface to send commands to our Arduino to send to the printer, then we call this update CMD processing command here. This looks a little bit sort of ugly, this line here, but all it does is it says, okay, read from the serial interface into the buffer we created, and then look over that buffer using the parser. When the parser has looked over the buffer, if it finds any of the recognized commands that we defined in the callback, then process them. Okay, so this is all related to this thing we defined earlier, where we had our buffer, our callback, and our parser. And remember, we created them in the global section as here. So we copy from the serial interface into the buffer. We look through the buffer for any of the callbacks, which we added here. And if we find them, we process these 3 commands which we had at the bottom. Otherwise, if we're not using the serial interface, well, that means that we're using MQTT instead. So we go into this loop instead. We'll just make sure that we are connected to the network. I mean, a serial interface, that can't really, you can't really drop a connection to that, to be honest. So long as no one's actually pulled the wire out, that should stay connected pretty well. But when you're using Wi-Fi or Ethernet, there is obviously a little bit more risk that whatever, the server's gone down or something like that. So we add just a little bit more sort of error checking here. We check that we are still connected to the MQTT server. If we're not connected, what we'll do is we'll just try to reconnect again using the same device as before. We will register for any topics intended for this device. So again, the way I structure my projects when I'm designing these things, so my MQTT topic structure is always to begin either with the word to device or to host, depending on which way the message is being sent. And after to device, I have the device ID that this message is being intended for. So if you only want to send a message to this printer, you'd include to device, and then the device ID, which remember I defined at the top was 100. And then after that, we have any subtopic. So the hashtag there, that is a wildcard symbol for any subtopics that were published to the device ID under to device. This device will subscribe to. So the subtopics in question are actually feed, LED, and print in this case, because I created a topic for each action we want the printer to do. Some people create a single topic for the device, and then you actually put the command as the first part of the message payload. There's no right way to do that, it's totally up to you. But the advantage I found of doing it this way, of actually putting the action in the topic structure, is that when you get to the message, you know that it is all kind of payload, as it were. But that's up to you. It doesn't really matter. The main thing is that whatever you subscribe to there is going to be what you publish your messages to from Node-RED or from whatever MQTT device you have. So we subscribe to that topic. If we are unable to connect to the Node-RED server, then we'll just output some information about what that failure to connect was. We'll wait 5 seconds and then we'll try again. So this will enter a loop while it just continually tries to create that connection, and then when it is connected, it will just ensure that we are subscribed to the topics that we want to listen to that will send those messages. And lastly, we will just call this loop. So this loop here is a little bit like the loop for the serial connection we've got here. That will just send any queued up messages, it will receive any messages that have arrived, and it will process them according to the callback that we defined up here. And then finally, we'll just put a little bit of delay just to slow down the code execution. You really don't need this to be running 1,000 times every second, so that will just make it a little bit more efficient just by slowing down the processing. And that is all the code. Okay, so if you were to connect your device via USB and upload this sketch onto it, this would be ready to use. You could actually load the serial monitor here, and you can send a message to the device. So you could say print this is your test message, for example. click send, and that would print out of the printer. However, you probably don't want to keep the Arduino IDE open where your escape room is running, and I did show you a Node-RED dashboard at the beginning of this video. So let me show you how you can create that instead. So here I've got my Node-RED instance running on my server. I've spoken about Node-RED in lots of my previous videos. It's an amazing piece of free software. You can use it for connecting all sorts of hardware and software and web services together, and it's brilliant for escape room programming as well, getting prop devices to talk to each other. And it's just really well thought out in loads of ways. So for example, if I just import the setup which I've been using, I can just paste it as JSON into here. I'll put this code on my Patreon link to download later. And if I click import, it tells me it's imported a new flow with 38 nodes in it. And here it is. So this is my entire structure which I used to create that dashboard earlier. And in fact, if I just deploy that, remember that this is what it looked like. So I've got an LED toggle on and off. I've got my list of predefined hints here. This is where we typed in a custom message, and I've also got my image. So if I just show you each of the parts of the Node-RED that kind of created those different elements on the dashboard. So we start at the top. Now, in previous projects, I've typically used Mosquito as an MQTT server, and I would absolutely still recommend it. Mosquito is a fantastically reliable, very well tested MQTT server. However, Node-RED actually comes with its own built-in one as well. So certainly for testing, you might find it more convenient to use this one. It's one less extra service that you have to start up and things like that. So I've got a Mosca node here where I just define the MQTT port. Well, that's the standard port number, and I give it a name. And so long as you have this node in your Node-RED flow, that will actually start up a MQTT instance that's running in the background. So that's kind of a handy thing to do. If you're already familiar with Mosquito, if you've got Mosquito set up, I would encourage you to continue using Mosquito, but if you're not, this is a good alternative as well. So that's just setting up my MQTT server. And then this section here, so all these nodes here, relate to the predefined hints, so this section here. So first of all, I've got a drop down, and my drop down has in it my list of hints which I would like to be able to send. So obviously you can just add new options into this list, or you can overtype these with any of the messages that you might commonly and quickly want to be able to send to the players. And when that is changed, so every time that drop down is kind of revealed and a new value is changed, it sets a variable called flow.hint to the message.payload. So message.payload is the value that was selected in the dropdown, and this just sets a flow variable. So the flow context, this is a little bit like setting a global variable in Arduino code. So it's going to be a value that we can pick up from other nodes in the flow. So it sets the hint to whatever the last selected value was. Then when we click on the send button here, what we want to do is to actually send whatever the last hint was that was selected. So this is the button that we click that actually makes that action happen. And we've got two choices as to how we're going to send it. We could send it via MQTT, that's these two nodes, or we could send it via serial, which is these two nodes at the bottom. Let's assume we'll look at the MQTT one to start with. So now what we do is sort of the inverse of what we did in this node. So here, when we change the drop down, we set a global variable called flow.hint to whatever the hint selected was. Now we're going to set the message payload to whatever hint was. So we're going to retrieve what the hint was that was set last time the combo box was selected, and we're going to pass it along this part of the flow. Now that may seem a little bit kind of convoluted. It's basically because the action of selecting the hint to send is not connected to the same flow as when you actually send the hint. You know, you might choose this and then sometime later do something over here, and then only click the send hint button. And what you expect is for whatever the previously set hint was to be sent at this time. That's why we're having to store it in a variable in the meantime, basically. So that's what this flow.hint does. It's remembering whatever the last value was. We'll then send that along in the payload of this line of messages here, and we will send it to our MQTT server. So Mosca, we're using this instance. If you were using Mosquito, you could set a different MQTT broker here, and you just input the parameters of the IP address and the port number here. We'll send to this topic. So remember that this was the topic that we set in the Arduino code itself. So it always begins with toDevice. Then it was the device ID, which we set to 100. And then the last topic is actually the action we want to do. So in this case, we're going to print. What are we going to print? Well, we're going to print the message payload, which was set up here as the flow.hint. So that's how we send to MQTT whatever the parameter was that was set in the dropdown. To send it via the serial connection instead, well, we've got a different branch here. So here we're going to actually build up that serial message that we type. So the serial message begins with the word print and then a space, and then we put in the hint again, so whatever the value selected in the dropdown was, we'll just put it surrounded by double quotes on either side. So that just ensures that the space values in our hint don't get accidentally kind of interpreted as delimiters or something. It sends the whole hint with speech marks around it. And we send a trailing carriage return and new line at the end. That's important so that when the Arduino or the ESP receives this message, it knows that it is the end of the message. It knows that there's no more part of the text string still to be received. So that's kind of like the message ending format. After that, we're actually going to feed the paper through a little bit as well, so we can read the message that's just been printed. So we'll send the first message, and then we'll append onto the end of it. We'll feed 2 lines worth after that. And again, you know, you could carry on building up this message if you want. We could then print another message after it by just appending more and more stuff to this message payload. And finally, we take whatever the payload constructor was and we send it to the COM port, which is wherever our device is plugged into. So again, back in your Arduino serial monitor, where you upload the board normally, you choose the port number here in this drop-down, and whichever serial port you would normally use here to upload your code to is the same serial port that we're now going to connect to from Node-RED instead. So that is all how the predefined hints section works here. The custom message, well, that's actually really very similar, except in this time, instead of having a combo drop-down up the top here, we've got a free text input box. And whenever that is edited, we set a new, again, kind of like a global variable, which is a variable in the flow context. And this time we'll call it message. So the last one was hint, this one's going to be message. And then when we click the send message button, again, we retrieve whatever that message was. We set it equal to the message payload, and we'll send it to the device to the print subtopic. We'll publish it there, and that's where the MQTT device will pick it up from. Again, in the serial message, really similar. We print the message, we send a carriage return at the end, and then we'll just send a line feed of 2 lines just to get the printer to kind of spool out a bit of paper so we can actually read it. The LED, well, this is nothing to do with the printer functionality, but this is just a useful little thing to add, I find, just to make sure you haven't got any problems with the printer itself. One thing I noticed with these printers, by the way, is if they don't have paper in them, for example, there's no easy way for them to display like a paper out warning or anything like that, so they simply won't do anything. So if you find that your printer isn't responding, it's always useful to have some kind of method of just checking the communication with the device. So that's the reason why I put this code in here. So here I've got a toggle switch, and the 2 values when it's toggled on and off are, unsurprisingly, on and off. and we'll send those to the LED topic of the device with the ID 100. So again, that's our controller here, and we'll either send that via MQTT or once again via the serial connection. You guessed it, we set LED, and then this is going to either be on or off, and then we send the carriage return there. And you can add more cases as you want. I will put the code download up anyway so that you can install this simply by going to the import and pasting the code in here. But you don't have to use Node-RED at all. I should point out, if you have another control system that uses MQTT, so there are several off-the-shelf escape room control software products that I'm aware of that use MQTT. If you have one of those, you can absolutely use one of those to control this thermal printer instead. If you don't have anything, like I say, you can very simply use any software that's capable of sending a message via a serial connection. So the simplest one of those to simply test it on is the serial monitor here. I wouldn't personally recommend you use that in a production room, but it's absolutely good enough for testing purposes. Yeah, so there we go. So hopefully this video has given you some ideas about how you can use a small, cheap thermal printer like this one as a way to generate dynamic printed content for players in an escape room. As always, I will copy up the Arduino code and the Node-RED code and the wiring diagram and all that I'll put over on my Patreon account, and I'll put a link at the bottom. I really enjoy making these videos, and I am very lucky that I have the support of some amazing patrons that enable me to carry on doing so. So thank you very much to everyone who supports me in being able to do these. If you are able and would like to support me, do check out the Patreon link below. I do put goodies on as well that are exclusive for Patreon subscribers. If you can't or don't want to, that is absolutely fine as well. You can always follow along the video that I put up here. I will always keep on posting my videos for free on YouTube, and you can just follow along. And you know, you can always ask me in the comments below if you have any questions, or if you end up making a prop that uses a printer like this. I always love hearing about or seeing pictures of anything that anyone's made. I really enjoy doing that. So this has ended up being quite a long video in the end. If you've made it this far, congratulations. Thank you for staying with me. But I will look forward to seeing you next month with a new project. Okay, cheers. Thanks for watching.